Objectives for 1.6. Number 1, solve polynomial equations by factoring. Number 2, solve radical equations. Number 3, solving equations with rational functions. Number 4, solving equations that are in quadratic in form. I put too many n's in that sentence. I'm sorry about that. Solve equations involving absolute value and solve problems modeled by equations. So what's this last one going to be? You remember? So like word problems about all these other things? Okay, that's when that one's going to be. Okay, so again, this is a lot of different things. This covered actually a lot of different units and chapters in Algebra 2. So we'll just pull it all together today, all right? So first of all, solving polynomial equations by factoring. Okay? 2x to the 5th plus 10x to the 4th equals 0. Okay? 2x to the 5th plus 10x to the 4th equals 0. So if this is the problem I give you, what should we do first? Anytime we're trying to solve an equation, we want to see if there's anything that we could factor out of both terms. We want to try to find the greatest common factor. Okay? What is the greatest common factor between these two things? So both of these numbers are divisible by 2, right? And that's the biggest number that they're both divisible by. And x to the 4th is also the biggest variable they're both divisible by, right? Okay? So if I divide a 2x to the 4th out of the first term, what do I have left? X. What if I divided 2x to the 4th out of the second term? What do I have left? 5. Excellent. Now, yesterday we talked about the fact that if a times b equals 0, then we know either a equals 0 or b equals 0 or both. And just to cover all our bases, what do we always do? We always do both, right? So we're going to take 2x to the 4th and set it equal to 0. And we're going to say x plus 5 equals 0. So to solve the first equation, well, I mean, I could go through all the steps, right? I could divide both sides by 2 and take the 4th root of both sides. But I know it's going to be what? 0. Okay? What about the right-hand side? What would I do here? I would subtract about 5 from both sides, so I would get x equals negative 5. Okay? Well, what if the equation didn't look like that? What if it looked different? Would you know what to do? Well, x to the 3rd plus x squared plus 5x plus 5 equals 0. We talked a little bit about factoring something like this in the last section, in section 1.5. But there's 4 terms, right? When there's 4 terms, how are we going to factor this? We're going to factor by grouping, right? We're going to look at the first 2 terms together, and we'll look at the last 2 terms together. What's common? What's the greatest common factor between the first 2 terms? X squared. If I divide an x squared out of each term, what's left? Yes? And 1, right? Okay. What's the greatest common factor in the last 2 terms? 5. If I divide a 5, what's left? X and then plus 1. Excellent. Now if I look at this term right here and this term right here, what's common in those 2 terms? X plus 1. And if I factor out an x plus 1 from each term, what's left? X squared plus 5. Once again, if a times b equals 0, either a has to be 0 or b has to be 0, or both. We never want to miss an opportunity to get the answer right, so we always do both. So here, of course, I want to subtract 1 from both sides to get x equals negative 1. Here, if I subtract 5 from both sides, I get x squared equals negative 5. How do I undo a squared? Square root. X equals what? Oh, excellent. Well, almost excellent. Yeah, for sure. Plus or minus. Any questions about that? Okay. Any questions about solving equations by factoring? Basically, a bunch of the stuff we did in section 1.6, but we're solving it this time. We're not just factoring it and be done. We take the factors and set them equal to 0 and solve each term. Okay? All right, so radical equations. Let's solve radical equations. So what if we have this? 2x minus 1 plus 2 equals x. Whoa, sorry. All right, so how are we going to solve this? Well, we want to isolate our radical, don't we? To isolate the radical, we have to subtract 2 from both sides first, correct? So the square root of 2x minus 1 equals x minus 2. How do I undo a square root? Square that whole side, square that whole side, right? So what's left on the left-hand side of the equation? 2x minus 1. What's left on the right-hand side of the equation? That's what I was afraid you would say. What? Yes. Yeah. Squaring something is multiplying it by itself. So I have to do this. Remember? So x times x is x squared. X times negative 2 is negative 2x. And then negative 2 times x is negative 2x. So that gives me negative 4x. And then negative 2 times negative 2? Positive 4. Now, how do I solve it from here? Any guesses? Or any no's? For sure, we want to get it equal to 0, don't we? Okay, so we could subtract this side and move it over here. We could subtract this side and move it over here. You guys remember, hopefully, that I like to have a positive x squared term if possible, right? Because that makes factoring easier if I can do that. So let's subtract 2x from both sides, and let's add 1 to both sides. Okay, if I do that, I get x squared minus 6x plus 5. So again, thinking back to yesterday when we talked about section 1.5, this is just factoring now, isn't it? So it multiplies to be 5 and adds to be negative 6. Negative 1 and negative 5? Yeah? Once again, two things multiplied together to give me 0. So I need to take each one of them. Yep. Perfect. Set it equal to 0. Add 1, add 1. X equals 1. Add 5, add 5. X equals 5. So something I did a poor job of on these two examples. Can we go back to these real fast? What did I not show you? What did I not do for you on these two examples? We know the answers are right. How? Because I said they were the right answers? We had to plug them in. We had to check, right? 0 to the 5th is 0 times 2 is 0. 0 to the 4th is 0 times 10 is 0. 0 plus 0 is 0. That works, right? Negative 5 is a little bit more difficult, isn't it? Negative 5 to the 5th power. I don't know that one off the top of my head. Sorry. Is it? 3,125. Pretty close, though. Okay. So then times 2, right? To give me the first part of that, which is, well, oh, dang it. I added 2 on accident. There. Negative 6,250. Then I need to add 10 times negative 5 to the 4th power. That equals 0. So does that one work? This plus this equals 0. I got 0. 0 equals 0. Yeah, okay. Negative 1. Negative 1 cubed is negative 1. Plus 1 is 0. 5 times negative 1 is negative 5 plus 5. 0. 0 equals 0. That works, right? This one's a little messier. For time's sake, can you just trust me to know that if you plug it in, it works? Are you okay with that? Both of them, both the positive and the negative. You okay with that? Excuse me. So everything we've done so far has worked. So is it really that important to check answers? It really is. Okay. Which one do you want to try first? 1 or 5? 1. 2 times 1. 2 minus 1. What's the square root of 1? 1 plus 2? 3 equals 1. Did we do something wrong? No, we did not. It doesn't work, right? Do you remember what this is called? It's an extra solution we got when solving that just doesn't actually work when you plug it in. What about 5? What's 2 times 5? 10 minus 1? Square root of 9? 3 plus 2? 5 equals 5. That one works. This one's fine. Okay. So why did we get 2 answers if there wasn't a squared in the original problem? Didn't we square it to isolate to undo the radical? So we created a squared problem when there wasn't a squared in the original problem. That's how come we ended up getting 2 answers, but only one worked because we're only supposed to get 1. Okay? So what about this? This doesn't look like a radical function. So tell me why it is. So I guess technically it's not a radical function, but since we have a rational exponent, that's like a radical, right? Because this is a power and this is the root. It's the 3rd power, but a 4th root. So it's like if we had a root like this, but with the 4 in front. Do you remember that? So how would I go about solving this problem? For sure, right? Basic problem solving skills or equation solving skills we start with. And then divide by 3. So x to the 3/4 equals 2. How do I undo something to the 3/4 power? I raise it to the 4/3. How is that related? It's a reciprocal, isn't it? Okay. So depending on what the question asks for will depend on how you answer this question. Okay? Because first of all, 2 to the 4/3 power is a perfectly fine answer. If it wants it in radical form, you need to say the top is the power, the bottom is the root. So it's the cube root of 2 to the 4th power, or the cube root of 16. Right? But what if it says, simplify, round to 3 decimal places, or round to the 1,000th? What does it want you to do? It wants you to say 2 raised to the 4/3 power. Does that make sense? So you're going to have to go by what the directions say there, or what the problem says there. That would be 20, because it's 198. So that would round to 0.520. If it says round to the 1,000th, then you need a decimal. If it says write it in radical form, it wants it in radical. If it says write your answers with rational equations, it just wants this right here. Okay? So that's one of those things that God bless you, you're going to have to be flexible about when you get to the actual question. Okay? So what about this problem? Let's do another one of those, because it has been a while since you've seen those. That should be a minus. Sorry. This is a minus. Oh, you can't even see it. This is a minus. Pretend I wrote the right problem. This is a minus. So let's add 3/4 to both sides. X to the 2/3 equals, what's negative 1/2 plus 3/4? Isn't this the same as 2/4? What's negative 2/4 plus 3/4? 1/4. It's the same as 1/2. I want to combine these fractions, but I can't do that without a common denominator since I'm adding or subtracting. So let's raise it both sides to the 3/2 power. Top is the power, bottom is the root. We can do this one in our head. What's the square root of 1/4? What's square root of 1? What's square root of 4? So 1/2, right? What's 1/2 to the 3rd power? Okay. Now the only thing we're missing is this. What's the square root of 1/4? We said 1/2, right? But what's the real square root of 1/4? Isn't it plus or minus 1/2? Because it's a square root, it's an even root, so we have to take both the plus and the minus into account. Because when I raise it to the 3rd power, 1/2 times 1/2 times 1/2 is 1/8. But negative 1/2 times negative 1/2 is positive 1/4 times negative 1/2 is negative 1/8. So I'm going to have plus or minus 1/8 right here. Does that make sense? When we plug this in right here, 1/8, well, 1/8 to the 2/3 power, the cube root of 1/8 is 1/2. 1/2 squared is 1/4, right? 1/4 minus 3/4 is negative 2/4, which is negative 1/2. Negative 1/8, the cube root of negative 1/8 is negative 1/2. Negative 1/2 squared is 1/4. 1/4 minus 3/4 is negative 2/4 or negative 1/2. Does that make sense? Okay. So far I've shown you examples of solving polynomial equations by factoring, solving radical equations, and solving equations with rational exponents. That's all stuff we did in Algebra 2. Okay? Solving equations that are quadratic in form is something I think that you'll be okay with because we did solving quadratics in Algebra 2. But sometimes the quadratics or the polynomials they ask us to solve aren't quadratics, but they are quadratics in form. Like this. Okay? So I'm going to show you 2 different ways to do this problem. I need you to know and have seen both ways because it's going to ask you in your homework about both ways. Is that fair? Okay. So do you understand that this is quadratic in form? For example, this problem that I did when we got, where is it? It wasn't there. Okay, I thought we did one today already. I guess I can't find it. Oh, yeah, right here. Sorry. This is a quadratic, isn't it? It's x squared and x and a constant, right? So I could say, well, multiplies to be 5 and adds to be negative 6. And I said negative 1 and negative 5. Because when I take the square root of that and here, and when I multiply it back out, I would get x squared minus 5x minus 1x, which would be negative 6, plus 5, which would be here. Does that make sense? So this equation right here is actually quadratic in form, even though it's at an x to the 4th. Because I've got an x to the 4th here and then an x squared. If this was an x to the 3rd, it would not be quadratic in form. X to the 4th and then x squared and then the constant. So what I could do is just start thinking quadratic ways of solving things and saying what multiplies to be negative 9 and adds to be negative 8. Well, that would be negative 9 and positive 1, right? But what would go in the beginning of these parentheses? It can't be x, because to multiply, I might have to get x to the 4th. And to add these two and these two, I have to get x squared. So do you see that this would be x squared and this would be x squared? And then I would set each of them equal to 0 and get x squared minus 9 equals 0 and x squared plus 1 equals 0, where I would add 9 to both sides to get x squared equals 9. To undo my square root, or my squared, I would square root and get x equals plus or minus 3. On this side, I would subtract 1 from both sides and get x squared equals negative 1. I would undo my squared by square rooting, where I would get x equals plus or minus I. You okay with that? So in this textbook, they actually teach something called U-Substitution. Okay? U-Substitution can sometimes make problems like this a little bit easier because they can make them actually quadratics instead of us pretending it was a quadratic. Okay? I can say from the very beginning, I want x squared to equal u. Okay? I would rewrite this original problem, but instead of writing an x squared, I would write a u. Right? So this would be an x squared. What would this be? Or sorry, this would be a u, and this would be a u squared, right? Because in order to get from x squared to x to the fourth, I would have to square it, right? So I would have then u squared minus 8u minus 9 equals 0. Well, again, that's a quadratic, and I can easily solve that with minus 9 and u plus 1. Set each of them equal to 0 and get u equals 9 and u equals negative 1, right? But once I got to here where I have u equals something, I bring this back into the problem because u equals 9, but I know u equals x squared. So I would say x squared actually equals 9. And to solve for x, I would square root to get x equals plus or minus 3. And I know that u equals negative 1, but I also know u equals x squared. So I would say x squared equals negative 1. To undo the squared, I would square root to get x equals plus or minus I. Does that make sense? That's a U-Substitution. Okay? For the record, I used U-Substitution in some of my graduate classes on problems that were slightly more difficult than this. Yeah. What if this was x to the 9th? Would that work? If this was x to the 3rd, right? I mean, I could give you all sorts of examples like that. I can't have any really... I was going to say odd numbers, but I just told you x to the 3rd, right? This first term needs to be definitely a squared exponent. So basically an even exponent for it to work. Unless they all had an x and I could divide out an x to get this to be an even exponent. Then I could do it this way, or I could do U-Substitution, either way. Does that make sense? Okay. Any questions about solving equations that are quadratic in form? Okay. Then what's next is absolute value. We did absolute value in Algebra 2 for sure. We also did it right at the beginning of the year, so it has been a while. So I'm going to show you just a couple of these so that we can get through the examples. Is that all right? Absolute value of 2x minus 1 equals 5. Well, what's true about what's inside this absolute value? This answer right here can either be 5 or it can be negative 5, right? Because once I take the absolute value of whatever's in here, it's going to equal 5. Whether this inside is a positive 5 or a negative 5, right? So what we said is I take what's inside because it can be positive, but I also take what's inside as negative. Because it's not actually literally the 5 outside that's being positive or negative. It's what's inside that's positive or negative. Remember that? So here, I would just add 1 to both sides. 2x equals 6. Dividing both sides by 2 gives me x equals 3. I could always take just a real quick second to check that and make sure. 2 times 3 is 6. 6 minus 1 is 5. Absolute value of 5 is 5, so I know that that's correct, right? Here, I could either divide by a -1 from the beginning, or I could distribute through, right? Does it matter? What do you want to do? Divide by -1 from right now, or distribute? Okay? If I distribute through, I get -2x plus 1 equals 5. Subtracting 1 from both sides gives me just the x term. Well, I still have the -2 to mess with, but at least I don't have anything being added or subtracted on the left-hand side. And now I can divide everything by -2, which gives me x equals -2. Again, I could plug that back in, substitute it back into the beginning. 2 times -2 is -4. -4 minus 1 is -5. Absolute value of -5, 5. Does 5 equal 5? Yes, so those are my two solutions. Remember, a lot of times when we solve absolute value, part of our answer is a number line graph. Okay, where I have -2 here and 3 here. And -2 is an answer and 3 is an answer. But remember, anytime we're doing absolute value, you've got two solutions, right? Do you remember that? Think about it this way. How many solutions do we get when we do a quadratic? We get 2, right? Most of the time we get 2. And that's because if I graph it, it's a parabola. I know it's going to cross the x-axis 2 times. Even if it doesn't cross the axis 2 times, I know it's going to have 2 imaginary solutions, right? Because it is x squared. Okay? Think about what an absolute value looks like. Do you remember? It's a v, isn't it? How many times does it cross the x-axis? Twice. So we should get 2 answers. And if we don't, what's happening? That's happening, right? The vertex is right on the axis, so we only get 1 solution. But we'll still get it twice, won't we? Okay? Let me show you something to watch out for. How about that? Let's watch out for this type of problem. I want you to think about this problem with your brain. What does it mean to take the absolute value of something? So how far it is from 0, right? So it's a distance. So when am I going to take the absolute value of something and get a -4? When? Never. That's exactly right. If you have your absolute value isolated and it equals a negative number, that's a no solution. Because I can't take an absolute value of something and get something that's negative. Sometimes it might try to trick you, and it'll say like -8 right here, and then equal -4. Well, if I'm isolating the absolute value, I'm adding the 8 to both sides, and then that's not a negative anymore, is it? So just when you have your absolute value isolated, if it does equal a negative, that's a no solution. Okay? Now, just like we talked about earlier, this last objective is going to be like word problems associated with all these things up here. Sometimes reading charts, sometimes reading graphs. You've already seen some problems like that, yes? Okay? So do you have any questions about these objectives right here? And if you do later on, yay, ask. Okay? Any questions? Yeah, that's fair. And if you do, I don't mind if you ask. It's like kind of my job, right? Okay, awesome.